What we're going to be learning in this lesson is how to solve linear trig equations. What these are trig ratios in an equation that's in the form of a linear function. So what I've done here in the Minds On is put in some linear equations to be solved on the left-hand side, and then on the right-hand side, I have trig linear equations that are similar in form to the ones that you will have solved on this side. Now, there is one extra step that may be required in these linear trig equations. Sometimes you might have to do a substitution in order to get them to be the same trig function throughout the equation. So in this case, we have a cosec x, which is a reciprocal function to sine x. So in this case, what you'll want to do is replace that with 1 over sine x, and then go ahead and isolate or get sine x by itself. Similarly here, there's something you're going to need to do, and I'll let you think about that, with the sine and x and the cos x in order to get one single trig function that you can isolate. So I suggest that you go and solve these linear equations and then see if you can apply those strategies to solving these trig equations, then come back and check and see how you did. Now, and remember not to solve then for x with the trig ratios. At this point in time, all I would like you to do is just solve or isolate the trig ratios themselves. So this first linear equation, we want to get this 2 over to this side and change its sign, or subtract 2 from both sides, and then get the 3x to this side with the other x and change its sign, or else subtract 3x from both sides. What that leaves us with is x minus 3x equals minus 1 minus 2. Simplifying both sides, we have minus 2x is equal to minus 3. Then, dividing both sides by what's in front of the x, which is minus 2, that leaves us with x equal to 3/2. Now what we want to do is use a similar strategy on the other side using trig ratios. So once again, we want to bring this 2 to the other side and change its sign. And now we're going to bring the 3 sine x over and change its sign. That leaves us with sine x minus 3 sine x is equal to 3 minus 1 minus 2. Simplifying, we end up with minus 2 sine x is equal to minus 3. Now divide by what's in front of the sine x, which is minus 2 on both sides, and we end up with sine x is equal to positive 3/2. So hopefully you can readily see the similarity between solving these two equations, the main difference being that this is a sine x as opposed to an x. Coming down to the next equation, this particular one has a reciprocal function in it, so we really could do this a few different ways. I'm going to choose to invert and multiply. Now I'm going to put the 1 in there just to show what's happening. I really wouldn't need the 1. Minus x equals 1. Simplifying here, we end up with 3x, and we don't need the 1, as I said. Minus x equals 1. Now simplify both sides. 2x equals 1. Divide both sides by 2. And that leaves us with x equals to 1/2. Now, as I mentioned earlier, on this side, there is an extra step that we are going to have to do. We're going to take cosec x and replace it with 1 over sine x. 3 over 1 over sine x minus sine x is equal to 1. Now this question looks very similar to the linear equation on the other side. So we're going to use the same strategy. I'm going to invert and multiply. So I have sine x over 1 minus sine x is equal to 1. Simplifying, this is 3 sine x minus sine x equals 1. 3 sine x minus sine x leaves us with 2 sine x equals 1. Dividing by both sides by what's in front of the trig ratio, which is 2, leaves us with sine x equals 1/2. Hopefully you can see the next step of these is going to be to use our skills with trig ratios and solve for the actual angle x. Coming down to this next question, this is a very straightforward question to solve. Divide both sides by 3, and x equals 1/3. Now on this side, there is a wrinkle in this, in that it might not be evident to you how you will get these to be one trig ratio. What you have to remember is the relationship that tan x has with sine and cos. Tan x is equal to sine x over cos x. So what we can do here is divide both sides by cos x. That leaves us with 3 equals tan x. Now we're going to apply that skill of solving for the trig ratio to complete the whole question, where we actually solve for the angle as well. Looking at this first example, in this case, it's a little bit more involved because you can see that we have sines and coses in here. First thing I recognize is that there's a minus sine 2x on both sides. So I can actually end up canceling those out. So if I bring this sine 2x to the other side and make it positive, I will have 4 sine 4x is equal to 7 cos 4x minus sine 2x and plus sine 2x. And if you recognize that they could simply be canceled, that would be fine just to go ahead and do that. So what I am left with is 4 sine 4x is equal to 7 cos 4x. At this point, hopefully it looks familiar to you and the strategy is clear from what we did in the minds on. We have a sine x and a cos x on either side. So I'm going to divide both sides by cos 4x. That now leaves me with 4 tan 4x is equal to 7. I want to get the tan 4x by itself, so now I'm going to divide both sides by 4. And I'm left with tan of 4x is equal to 7 over 4. Now, before I continue, I need to think about this limit up here. Now, I see here that that says theta, but really it should be an x. So I'm going to change that quickly to an x here. So we have 0 is less than x is less than 360, but we have a 4x. We're going to use the strategy for solving a double inequality, and we're going to multiply everything by 4. So 4 times 0 is 0, less than 4 times x is 4x, and then 4 times 360 is 1440. what that tells us is that we will have to do 4 rotations in order to solve for all of the angles. So the next step is to do the inverse tan of 7 over 4. Calculating that out, second function tan 7 divided by 4. And this is in degrees, looking at the information in the question here, and my calculator is in degree mode. So that gives me 60.2 degrees, 60.3 degrees rounded. Let's round this to the whole number just to simplify our calculations. So we're going to round this to 60 degrees. So this is approximately 60 degrees. Now we're looking at the tan ratio, which is positive in this quadrant and this quadrant. If I write my cast rule to confirm that, and that means that I need a line in both of these 2 quadrants, so in the tan quadrant and the all quadrant. I'm just going to draw a line right across there. Ideally, it would be about 60 degrees. And then I'm going to complete my triangles while I'm at it. They don't look quite the same size. So the related acute is 60 degrees. And what we want to now do is solve for all of the different angles. I will draw the arrows for one of them. It will get messy if I try to draw all of the arrows for 4 rotations. So I'm just going to do the 1 rotation, and we can go from there. So we basically already have one answer, which is the 60. So 4x is equal to 60. And if we take the 60 degrees and we add 180, so 180 degrees to here plus 60, that's 240. Let's just show that work. 180 plus 60 equals 240 degrees. So that's our other answer from this initial rotation. So that's 1 rotation right there. Now remember that as we continue to rotate, for each of these terminal arms, the next value is 360 degrees away for each of these. So what I really only have to do here is simply carry on and keep adding 360 to each of those. So that's what I'm going to do. So 60 plus 360 is 420. 240 plus 360 is 600. There's my second rotation. Now I'll do it again. 420 plus 360 is 780. 600 plus 360 is 960. And I'm running out of room, so I'm going to come down here, and I'll do that one more time. 780 plus 360 is 1140. And finally, 960 plus 360 is 1320. The last step is we are solving for x, so we need to divide both sides by 4. So basically, all of these angles need to be divided by 4. 60 divided by 4 is 15 degrees. 240 divided by 4 is 60 degrees. 420 divided by 4 is 105. Then we have 150 when we divide 600 by 4. 780 divided by 4. It's 195. 960 divided by 4. Is 240. 1140 divided by 4. $285. And finally, 1320 divided by 4 equals 330 degrees. So there are all of the angles that satisfy this particular linear trig equation. Now at this point, if you feel comfortable with it, it would be a good idea to go ahead and try the other examples on your own and then come back and check them. This next question looks more like the others that we were working on. So here we again want to get all the trig ratios on the one side, numbers on the other. I'm going to bring this minus I'm going to bring this I'm going to bring this 2 sine theta over, change its sign. 4 sine theta minus 2 sine theta is equal to 1. That leaves us with 2 sine theta is equal to 1. Dividing both sides by 2, sine theta is equal to 1/2. The range is 0 to 2 pi, and using my cast rule, sine is positive in the first and the second quadrant. So that's where my terminal arms are going to be. So I need a terminal arm here and on this side. And if you want, you can figure out what angle is the related acute angle so that you can draw these somewhat accurately in terms of the size of the angle that you're working with. Now, when I look at this, it looks familiar. I'm just going to graph it or on the label these sides. So we have 1, and the hypotenuse is 2, and that sounds like our 1, 2, 3. So I know that this is the root of 3, and this angle is pi by 6, and so is this related acute angle. So because I see it, this is one of our special triangles, I'm going to do these in exact values. So theta is an angle here and here. Therefore, theta equals pi by 6, or 6 pi by 6s would be to this negative x-axis, right? And backing it up 1, that's 5 pi by 6. Coming down to this next question. This is another example where we have sine and cos on both sides. So what we're going to do is divide both sides by the cos of 2 theta. That leaves me with 4 tan of 2 theta is equal to 4. Dividing both sides by 4, tan of 2 theta is equal to 1. And once again, that's sounding familiar. Let's come over here. Our arms are going to be where tan is positive. And so tan is positive in the A quadrant and the T quadrant, or in quadrant 1 and quadrant 3. And again, I recognize that this looked familiar. That's 1 over 1 for the opposite and the adjacent. So that would mean that this side is 1, this side is 1. Here we have -1 and -1. And that looks like our 1, 1, 2 triangle. So square root 2 for the hypotenuse. And I know that this angle, and again I'm using radians, is pi by 4. And this related acute is pi by 4. The answer that we're looking for, based on the range that says 0 to 2 pi, would be this angle and this angle right here. Now in this case, we're doing 2 theta, remember? So 2 theta is equal to pi by 4. And looking here, this would be 4 pi by 4 to the negative x-axis and 1 more, so that's 5 pi by 4. Now at this point, I could have done it at the beginning. I didn't. I need to check this for 2 theta. So if I multiply everything by 2, it actually gives me a range for 2 theta of 0 to 4 pi. So I would need an extra rotation. So once again, I need to add 360 degrees, but in this case it's radians, so that's 2 pi. So I'm going to add 2 pi to each of these. I'll just show the work over here. So pi over 4 plus 2 pi, if we want that to have a denominator of 4, we would have to multiply the numerator and the denominator by 4, so that would be 8 pi by 4. So that gives me 9 pi by 4 as the next value. Adding 2 pi to 5 pi by 4. Now once again, the denominator is 4, so now I know that 2 pi is 8 pi by 4, so that gives me 13 pi by 4. My other two values are 9 pi by 4, 13 pi by 4. And then I'm really looking for theta, so once again, I need to divide everything by 2. Now keep in mind that when you're dividing by 2, that's the same as multiplying by a half. I'll do the first one written down here so you can make sure that you understand it. But other than that, we'll just go ahead and complete the rest without calculating them on paper or writing them down. So this ends up being pi by 8, right? Half of pi by 4 is pi by 8. So we're multiplying everything by a half. So this first answer we have is pi by 8. The next one, if we multiply that by half, would be 5 pi by 8. The next one would be 9 pi by 8. And finally, we have 13 pi by 8. And that's the last example. So you can go ahead and try this practice that's down here.